All right, so in this lab, we're going to do yet another reaction that we learned about. In this case, it'll be catalytic hydrogenation. And so in this reaction, we're going to take an alkene, react it with some hydrogen gas and some platinum, and reduce it down to an alkane. And so the cool thing about this reaction is that we're actually going to generate the hydrogen and the platinum in situ. So we're not going to add hydrogen gas or pure platinum to this reaction, but we're going to actually make it through the reagents that we add. And so for the hydrogen gas, what we're going to do is add some sodium borohydride. And so if we think about the structure of this, the sodium is just the counter ion, so it's just kind of hanging out there. And then we have the borohydride. So even though in this case the formal charge is on the boron, the hydrogen is actually more electronegative than the boron, and so this acts as a hydride or an H minus. And so this is reacted with some hydrochloric acid, right, which is essentially just H plus. And the electrons from this hydride can attack this H plus to generate some H2 gas, right, which is what we're going to use to do our hydrogenation. So that's where the H2 gas is coming from. And you'll see after we add the borohydride, our balloon starts blowing up. The platinum we're also going to generate in situ as well. The textbook has the full equation. But basically, we're going to start off with the chloroplatinic acid, right, which is actually a platinum +6. And then we're going to reduce it down to platinum 0, which is what's going to be catalytically active. And we're actually going to generate this as a colloidal dispersion, and so it'll have a lot of surface area there to react with our alkene. And the reaction itself is very straightforward, right? You just mix a couple things together, heat it for a while, and you get your product out. But the other complication with organic chemistry is not only do you have to do the reaction, after you're done with the reaction, we have to separate and purify our products so that way we can analyze them. And this step is often more difficult than the actual reaction itself. So one of the most popular techniques to separate and purify compounds is column chromatography. And so the idea of this is very similar to the other chromatographies that we've done. It's basically just based on the separation of things that move at different speeds. In this case, what we're going to use is called a column. So in this case, we're going to use a pipette. But a column is just basically any tube, and inside of here, we're going to have some kind of compound. In this case, and this is the most popular thing to use, is silica gel, which is SiO2. And this is a highly polar solid, and it has a very high surface area. And since this gel doesn't move, we're going to call this our stationary phase. And then we're going to push through here some solvent. And generally your solvent is going to be less polar than your silica gel. If you get too polar, you're actually going to start dissolving away some of your silica gel. And so we call this the mobile phase. Right, and overall we call this a column. And so column chromatography most often separates compounds based on their polarities, right? So we've got our silica gel in here, and then we're going to say we're going to try to separate a mixture of compounds, right? So we're going to separate this blue from this green, and we'll say that the blue is a very polar compound and the green is a non-polar compound. And you're going to toss the two in here. And then after that, you're going to add some solvent to push through your compounds, right? So they'll start off as a mixture up here. And then as you push through the solvent, some of them will prefer the mobile phase and some of them will prefer the stationary phase based on like attracting like and the fact that we have polar and non-polar compounds, right? So we've got our column here with some solvent. Our polar compound in blue will move very slowly because it prefers the stationary phase. While our nonpolar compound will move much more quickly because it's nonpolar, and so it's going to prefer the mobile phase. And so you can see what we have here is them moving at different rates. And so if they're moving at different rates, they're separating from one another. And so what we basically do is just keep pushing more solvent through and then collect fractions. Right, collect fractions of the solvent, evaporate off the solvent, and then see what you have. And hopefully it's your compound that's nice and separated. In our case, it's a little bit different. We're going to use what's generally termed as a plug instead of a column chromatography, but overall it's kind of the same idea, right? We'll still have our column, which is going to be a pipette. Inside of here, we're still going to have silica, and we're still going to push some nonpolar solvent through it in terms of our pentane. The thing that differentiates this from a column is that this silica is going to be with silver nitrate, and this silver is going to grab any alkenes. And so these alkenes are pretty much not going to move at all. So if we have our alkene in blue here, and then our alkane in red here, this alkene almost, I mean, you really have to push a lot of solvent through to get it to move at all, while our alkane, very nonpolar, will go straight through. And so the difference here is instead of both phases moving pretty much, or both compounds moving, pretty much only one compound moves, and the other one just kind of gets stuck. And overall, this makes the technique much easier. It requires less technique. Column chromatography requires a good bit of technique, and so it takes quite a bit of practice to get decent at it. And even then, it's very time consuming. This is much quicker. And so this is more akin to kind of an advanced filtration, but it still demonstrates the properties of column chromatography in a nice, simple way. So let's check it out. All right, so the first thing is going to be to make our apparatus, and this balloon part is going to be the trickiest part because it's got to be airtight. That way none of the hydrogen gas escapes. And so we've got our Claisen head right here. We've got our balloon right here. And then we've got this little kind of rubber band here that's going to keep the balloon onto the Claisen head tightly. So what you're going to do is twist this around twice, right, to make two little circles, just to make it tighter. Go ahead and then just pop that onto your rubber band. All right, nice and tight. Put this towards the bottom. Stick your two index fingers in here and spread it open, like so. And then just put it around your Claisen head here. It's a little bit tricky, but it shouldn't be too bad. And voila, we've got our rubber band on, or our balloon on, nice and tightly. All right, next up we're going to set up the rest of our apparatus. You can see I've got all my clamps and whatnot in here. I've got my 5 mil conical vial with a spin bar in there. And then I've got my Claisen head with the balloon on it. First thing, put this little cap on the bottom, like so. Add an O-ring. Pop this onto your Claisen, or onto your conical vial. Shut it down. And then to the top here is we're going to add our components with a syringe through this septum, right? So there's a septum right there that the syringe can pierce, but no gas can escape. So put that on there, and then just simply put it in our apparatus, and we'll start loading it up with the compounds next. All right, cool. So next up, we're going to start adding some reagents to here. So I'm just going to take this out, take the cap off. And so first up, we're going to add our 50 microliters of our chloroplatinic acid. As you can see here, it's a clear yellow liquid, so go ahead and just toss that in there. Cap it back up. Next up, we're going to grab our 1 ml of ethanol. So here's our ethanol. You can see as well it's a clear colorless liquid. Toss that into there. Recap. And then finally we're going to add our 125 microliters of the sodium borohydride. And then we'll add our sodium borohydride. Take this cap off. Add the reagent. And immediately put the cap back on. You can see it turns black almost instantly. And then we'll go ahead and recap this into here, put this into here, and start stirring aggressively. In the meantime, we'll make our octene and ethanol solution in this little vial that we can use a syringe to pick up. So I'll put 120 milliliters of the octene and 250 microliters of the ethanol into here. So we've got our octene and ethanol solution here. You can see they both were clear colorless liquids, and together they are a clear colorless liquid. Next up, we're going to add some hydrochloric acid using a syringe. So you just go ahead and open this packet up. Take out your syringe. Open up the sharp end tip point here. Put this inside of your syringe. And then you want 100 microliters, which will be 0.1 milliliters. So it's difficult to see, but the 0.1 milliliters is right under the 0.2. Lift it up so you can see. Right there's 0.1. Just fill it up to there, and that's how much acid you want. So you can see here I have 0.1 milliliters of liquid. You can see I've got an air bubble in there too, that's fine. And then you're just going to pierce your septum and insert your acid. Make sure it's going nice and straight down. That way all of the acid goes into the mix and not onto the glassware. Put that syringe to the side, be careful, it's sharp. And then we're going to add our octene solution with a fresh syringe. Just pick up all this solution, so just stab it in through here. And then pick it all up. Take it out and place it into your reaction vial. And crank up the stirring quite a bit as well. Probably should have had it up high the whole time. Place this off to the side, and then we're going to add our 1 ml of our sodium borohydride over a 2-minute interval. So next up we've got our 1 ml of our sodium borohydride. And then we're just going to add this dropwise, and then we should see some hydrogen gas forming and our bubble inflating. So just add it slowly. It says over approximately a 2-minute period. can see our balloon is starting to inflate. See, our reaction is getting a little bit white, cloudy. See, our balloon has totally inflated, so we're getting a good bit of hydrogen gas in here. And we've gone ahead and added all of the sodium borohydride. And then we'll just go ahead heat until this reaches about 50 degrees Celsius. Let's go ahead and turn on the hot plate to maybe 85. See how it goes. Let's turn the heat up to 100. And then off video, we'll just let this heat. Once it gets to 50 degrees, we'll let it heat for 45 minutes, but it's not too interesting to watch. So as you can tell, I've taken our apparatus off of the hot plate. You can see we still have a bunch of hydrogen filled in here, so that's good. If you take a look at our reaction, you can see we've got this clear layer, and then we've got a whole bunch of this white kind of cloudy precipitate. Let me see if I can see. If you mix it up a little bit, you can see it's a little cloudy, and that's probably the platinum. Not quite sure what the black specks are. They might be something with the platinum, or they might be a contaminant. Anyways, let's go ahead and open it up. It's back to room temperature, or at least about. You can see when we open it up, the release of pressure came out. We'll take this little septum off. Actually, never mind. I've got this cap right here. So we're going to use this foiled cap as our cap. But first thing we're going to do is we're going to add 1 ml of water. So I've got my water in here. It says HCl, but it's water. It's about half a pipette full. It's about 1 ml. Let's go ahead and add that dropwise. See, it's getting a little bit more cloudy. And now we're ready to go ahead and start extracting using our pentane. So we'll do 3 1 ml extractions. So first thing we need to do is add about 1 ml of pentane and then mix this up. We gotta get some pentane. So I've got some pentane in here. Push that off to the side. And grab out about 1 ml. Add it in here. Cap it with this aluminum covered cap. Give it a little bit of shake. Go ahead and vent it. And then shake it a little bit more. And then go ahead and give some time for the layers to separate out. So as you can see, they've separated pretty well. See this kind of black layer, you can tell the pentane's on top and then the aqueous layer's on the bottom. So we're going to go ahead and use our pasture filter pipette to pick up this top layer. And we're going to put it into this 25 ml Erlenmeyer that I've filled up with half a gram of some sulfate, some sodium sulfate to dry our pentane with. Cap this up so our pentane doesn't evaporate away. And then repeat this procedure. It's about 1 ml of pentane. Cap it up. Give it a shake. Let it vent. Cap it back up, give it another shake. Let it vent again. Cap it up, give it another shake. Let the layers separate. Good. Open it up. Grab another filter pipette and pipette it out. And repeat this process one more time. Got a ml of pentane. Cap. Shake. Vent. Shake. Vent. And then give it one more good prolonged shake. And then give some time for the layers to separate. And then one more pass filter pipette to go ahead and take out this final layer. Transfer it over. Cap this up and put it off to the side. We shouldn't have to use it anymore, but we won't throw it out until the end of the experiment. And then we'll let this dry for a couple minutes. You can see our sodium sulfate is still pretty powdery. Hasn't clumped too much, indicating we didn't pick up too much water. So just let this dry for a minute or two. All right, so we've let this dry for a bit. We're going to go ahead and transfer the liquid over into another Erlenmeyer. I don't have another 25, so I'm just going to use a 10 instead. So using a pasture filter pipette, you want to go ahead and transfer the liquid over. And then we're going to add another ml of pentane to the sodium sulfate flask just to wash it. And then we'll go ahead and just put this on a hot plate in a sand bath to let it concentrate. All right, so next up we're going to set up our little mini column. So first thing we're going to do is shove a piece of cotton down there just to plug up the bottom. That way all the sand and silica doesn't fall through. Got a nice little cotton plug there. Go ahead and place that in there. Try to make it nice and vertical, straight. Next up, we're going to add some sand, about 50 milligrams. So I've already weighed it out in this piece of weigh paper, so we're just going to go ahead and pour it in there. Give it a little tap so it all settles nicely. After this, we're going to add about 500 milligrams of this silica with this silver nitrate adsorbed onto it. Just give it a little tap. And then finally on top, we'll just add some anhydrous sodium sulfate, just in case there's any water left over. It'll suck it up before it goes into our column here. Cool. And now our column is ready to go. All right, so we've got our column over here. You can see it's above our conical vial that we pre-weighed with our boiling chip in there. So we're going to go ahead and weight our column with 1/2 ml of pentane. About 1/2 ml here. You want to try not to disturb the sodium sulfate layer on the top. Let all that liquid run through the column, and then using a Pasteur filter pipette, go ahead and put your crude sample onto here. So we have our crude sample in here.
concentrated. It all has to, because it's all based on how quickly it goes through.
Yeah.
So it has to hit the silicon at the same time. You know, if part of it starts hitting now, and then another part starts hitting later.
Yeah. I mean, you're supposed to wait until like all what's in there now comes out, and then add like a few drops, like that half mil of methane, just to push everything out. Yeah, it's gonna go slow.
One thing you can do to speed this process up a bit is just attach your bulb to the top and then just squeeze it a little bit and then pull it off, right? If you let go, it's gonna suck the air back up, so that's gonna be bad news. So you need to put it on, squeeze just a little bit, and then yank it off. So let's see if we can successfully do this. Cool. So we push that through, and then we want to go ahead and add another 1.5 ml of our pentane to elute through our little mini column. You can see when we've got some liquid up here, it's going to elute through a lot faster. It's just when it gets down to this bottom area here that it starts going extremely slow. So that was about 1 ml that we added, so let's go ahead and add another 0.5 ml. All right, so you can see all of our elutant is used up here. So we'll go ahead and stop separating or stop. Now we're going to go ahead and add an air condenser onto our conical vial. And we'll go ahead and let this heat in a hot sand bath for a couple minutes. and we'll weigh periodically until our weight is approximately constant.